Okay, ladies and gentlemen and students, we're up for another exciting night of recording. As if I have nothing else to do, which, let's be honest, we all have other things to do, but this is important. So I'm grading some of your water on a penny labs, and I just wanted to explain to you, even though we've gone over this for the several weeks now, I want to explain to you what I'm looking for. And even though I have given you a sheet of paper with two examples of exactly how this should be written out, let's assume they fell out of the books and got lost. So for this lab, the Water on a Penny lab, this is really what I'm looking for. Your name, the date, and the class. I'm in class 101. Type of lab, we're going to call this Water on a Penny lab. The problem must be identifiable and stated as a question. For this, we'll say, how many drops of water can a penny hold? So, some people might have written, what is the maximum number of drops of water on a penny? I'm okay with that. How about, what is the maximum of drops of water on a penny? I'm okay with that. And what is the maximum number of drops of water on a penny? I just happened to pick these three labs out that I graded so you could see what I'm looking for. Okay, so hypothesis has to be testable. If water is dripped onto 3 pennies, and I'm going to say we're just picking different dates, age 80, 90, and 2000, then the 1980 penny will hold 5 drops less than the 1990, and the 1990 penny will hold 5 drops less than the 2000. This is because the older penny has more wear than the newer penny, and the sharp edge is most likely worn down, preventing water from staying on top. Sounds reasonable. You have a if, you have a then, and you have a because. Materials, 3 pennies, 1980, 90, and 2000, a disposable pipette, a beaker of water, and a paper towel. So look over here. As I told the classes, I'm really not concerned about a magnificent drawing at all. I do not expect students to do anything that I can't do. I can't draw. So a little drawing like this take you a few seconds. So you know, it took me about 25 minutes just to make this lab up. You should already have the lab over the course of 2 days written in your notebook. All that has to be done is to be copied onto this piece of paper. Here's our experiment and diagram. I would draw the diagram first to give you an idea what you're going to be writing when you're first setting up the lab anyway. Number 1, place 3 pennies on a flat paper towel. Number 2, drip water slowly onto the 80 penny until it runs over the edge onto the paper towel. Record the number of drips. Repeat steps 2 and 3 using the 90 penny. Then the next step is repeat steps 2 and 3 using the 2000 penny. And let's go down. We can go right over to our data table. Let's skip over the conclusion. We're going to go right over to our data. So remember that you have to identify what you're putting on here. So I put the trials in columns like this, and the number of the date of the pennies across here. So I did 4 trials, and I averaged out at the end. So here's our average. The only thing that we're going to be graphing is the average, and I have said this many times. So let's go over here. You also have to say what it is you're working on, where the trials are, and exactly what your outcome is. So you have to identify and label everything. That brings us down to the graph. Now, the graph, on the x-axis, we are going to be what we are changing in the lab. It doesn't matter. Amount of fertilizer for a plant, amount of sunlight for a plant. Anything we're changing is going to go on the bottom. So on here, we're changing the pennies. And I want you to notice that when I made a mistake here, which I carefully, purposefully did, I did that so that you could see if you make a mistake, put a line through it, and put the right answer. No need to run your pen over this, and as I've said many times before, like this is some KGB or CIA or FBI secret that nobody should be looking at. So we don't have to just sit here for a few minutes crossing this out. La, 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 la. We don't have to do that. We just put a line through it. because now we see that we've made a mistake. We're not going to do that again. Come over here, and we are going to have what is changing as a result of what we're changing down here. So on the side, we had water, and the units would be number of droplets. Down here, we had penny, and the unit would be the year. I am going to show you how to do a graph this week, so we're going to talk about this, and I'm sure that many of you know that this little double line here is called a, yes, it's called a break. And we are cutting that piece out because we don't need from 0 to 16. Our lowest number is 17, so we're just cutting that part of the graph out, starting at 16 and giving us a nice area to work with. So after I did this, I just wanted to make a note on the graph for myself, so when I write the conclusion. So I had said that it would be holding more with the newer pennies and holding less with the older ones. Turned out it was just the opposite. So what I want you to do is make a note on here so that when you go back to your data, you have some kind of a general idea what you're looking at. I think we have about, I think this video will run for about 15 minutes, but I want to make it kind of short. As entertaining and enlightening as these videos are, I don't want to keep you here all night. So does everybody get this? Make a note on here. This should be in your notebook. You have graph paper in your notebook. So by the end of the second day, and you go home at night, you should be able to write this out. No problem at all, okay? So let's take a look and see what our conclusion is. So it says the data does not support the hypothesis. Or you could write it, the hypothesis is not supported by the data. Or you could say, the data denies the hypothesis. Or you could say the hypothesis is denied by the data. Anyway, any way you want to do that. You just cannot say the hypothesis is wrong or the hypothesis is right. There is no such thing as a right or a wrong hypothesis. Either they are proven or not. Every hypothesis that you write that is testable is right. So I said does not support the hypothesis. Each year held the following number of drops: 1980, 21, 1990, 18, 2017, which meant that as they got newer, they held less. So it says this shows that the newer pennies had fewer drops, and the hypothesis stated the opposite. Upon closer inspection, the newer pennies were more worn out, while the older one was in great shape. It had a higher outside ridge, able to hold more water. Now, this should all be in your notebook, so when you come in Friday, all you're doing is copying this from your notebook onto the paper. The reason I have you do it in class, if I have you do this at home, these labs used to come in a week late, 2 weeks late, sometimes never. So let's take a look at this one here. You notice I blanked out the names carefully to protect the innocent. So this one, I'm going to come back to that one because that one wasn't bad. Let's take a look at this one. Title of lab, water droplets versus numbers. Just numbers. Let's just say it's water on a penny lab because that's what the PowerPoint says, and that's what we were talking about in class. Here's the hypothesis. If you put water on different places of the penny, how many droplets will fit in it? Makes no sense. If you put water on different places, we don't know what the places are. Of the penny, how many droplets will fit in? So if we don't know whether we're using 1 penny or 3 pennies, or what these different places are in the hypothesis, we cannot do the experiment. This is not testable. This is a question, and it's not a testable hypothesis. And I do say specific quantities for the materials: water, penny, and a dropper. How about that paper towel? Diagram. I have put this on all the forms, and rarely am I seeing diagrams. I did see a couple more than I have seen in the past. The procedure was written down here. We're going to skim through that. And then what we're going to do is we're going to go over onto the findings here. So I'm okay with these hash marks. I like this, but I want you to tell me what they are. If this is drops of water, I want you to tell me those are drops of water. I am perfectly fine with this. Let's see. And if you have head center, heads any side, and tail center, either you're going to do all three heads or all three tails. Center, side, and middle of the radius. I did mention this. Or you could just do heads and tails. Simply do two of them. And I said it's the only lab where you're going to be permitted to do two. I think we're kind of running out of time here. I got a few minutes left, though. How about a title? We need a title for the graph. And I realize that putting the graph on, I said you could do this freehand. If you could be a little neat, I'd be happy about that. No label, no units. No label, no units. Just three skinny towers. Okay, and the conclusion, in confirmation, that's spelled incorrectly, but in confirmation, you don't write that. This is the conclusion. Depending where you put water, it will change how much water there is. Okay, don't know what that means. It's not a conclusion. It's not supporting or denying your hypothesis. So let's move on to the next one. Let's go back to this one because this one was pretty decent. Okay. This was not bad. Put a little smiley face on. If you get a smiley face from me, you're lucky. Title on lab, water on a penny lab. Problem, what's the maximum number? Hypothesis. If we drop water on 3 different age pennies, I would like to know what the ages are. Because if you don't know what they are, you can't do the lab. It's not testable. But this was almost testable because this was about the best I saw today. Then the 1991 coin will hold the most water because it has excellent conditions. Maybe you could explain what those conditions are. Maybe the ridge around the outside, maybe not as flat. Materials are correct. Don't get carried away with your diagram. Take the following materials, irrelevant. Take the dropper and fill it with water, irrelevant. Dropping water on the pennies and see which holds the most water and record that data, very relevant. So then you would do step 3 again with the next 2 pennies. You do not have to draw 3 droppers. We assume that you're dropping it on them all. I like this diagram, though. Our data does not support our hypothesis. Why? You need to give us some kind of data or support on the bottom here. But, again, this was one of the better ones, so I kind of ran with it. Got a 4 out of 5. This should be more complete, as should the hypothesis. Data table clearly points out the drops. The average could say year of penny up here, even though we know that's what it is. But also written bad condition, okay condition, good condition. We don't need to know that right now. Then we come down to our graph. Water drops versus dates. How about number of water drops versus the dates of whatever? We have our water drops over here. Water is our label, drops are our unit. And we have this over here, which shows us our date. This would be year of penny. Okay, so this is going to finish in about a minute or so. So I just want to wrap this up, show you what I'm looking for. Let's take a look at our last one. So you may see invalid down here. If your hypothesis is not testable, your conclusion has to be invalid. No. So if you say your conclusion is just no, that sounds like, no, I don't want to eat that. No, I don't want to go outside. I believe you mean, no, this does not support your hypothesis, but you have to write that. No, because 1988 penny was able to hold the most amount of drops. How about of water? Let's not forget that. No diagram. Let's go on to the back of this one. Oh, labels. Let's know if you put D here, day, daytime, David, dinghy, driving. Let's put D equals drops. And what else? Oh, we're missing a few things on here. You're making up your own intervals. Not a good idea. Use the boxes. Anyway, that is it. If you have any questions, feel free to ask. And I believe we are about at our end right now. Thank you.